Trig equations and identities bookwork, page 1. So section A, a linear equation has one solution. Quadratic equations have at most two solutions. Trigonometric equations have infinite solutions. Unless a restricted domain such as, and then you could put anything here, you could put like negative 2 pi less than x is less than pi, or something like that. Okay? Basically what this is saying is, if you have a line, if you have a parabola, if you have a sine wave, all of these have different numbers of solutions when you say, okay, when does the line equal 3? When does the parabola equal 3? When does the sine wave equal 3? So you can see here that the line has one solution, the parabola has two solutions, and the sine wave has 1, 2, 3, 4, 5, 6, goes on forever, has an infinite number of solutions, unless you say, oh, I'm talking about from here to here, and then that'll limit the solutions to 3, for example. Okay? So, moving on. There's a few ways to solve an equation with a trigonometric function in it, and one of the ways is graphically. So here they show some graph paper with sine waves drawn on them, and they're going to ask us to solve equations such as, like this is a cosine equation, right? And you can tell, even if they don't say it's cosine, you can tell it's cosine because it starts at 1, and then it goes down to -1, and it comes back up to 1, so that's cosine typically, right? So use this graph of y equals cosine of x to find, correct to one decimal place, the solution of cosine of x equals 0.4 for the range, or for the domain 0 to 10. Okay, so they're saying 0 to 10, so that would be from here to here. So they want all the solutions where cosine of x equals 0.4. Let's try to draw a line 0.4. I think it's about here. Wow, I'm drawing a really straight line here. Okay, it's about there. Okay, so let's mark where the solutions are. Where does this red line cross the black sine wave? Well, there, and there. Okay, so let's try to find out what the values of x are for this. So I draw a line down. I draw a line down. Draw a line down. Okay. So this one looks like maybe it's like 1.2. This one looks like maybe it's like 5.2. And this one looks like maybe it's like 7.4. Okay, so those are my guesses. Okay. Then the next one says cosine of x equals -0.3 for the domain 4 to 12. So let's see, 4 to 12, that would be 4 to 12, it would be between these two, okay, and we want to know when the cosine of x equals -0.3, so that would be about, maybe a little bit lower, maybe like there, okay, so that would be how many solutions? There's one there, one there, one there, and one there. So let's see what those are. That looks like it would be about 2. This one looks like it would be about 4.4. This one looks like it would be about 8.3. And this one looks like it would be about 10.7. Okay, so basically you just draw the line across horizontally, and then you find the place where it intersects, and then you see where those are located on the x-axis. Now let's do number 3. Use the graph of y equals sine of 2x to find, correct to one decimal place, the solutions of. So here we have sine of 2x equals 0.7. for the domain 0 to 16. So 0 to 16 is the whole thing, okay? Sine of 2x is the graph here, and they say when is it equal to 0.7? So let's try to draw a line at about 0.7. I think it's about there, okay? So man, there's a lot of solutions, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's see, where are the solutions? That's one, it's like 0.4. Here's another one, it's like 1.2. Here's one, it's about 3.6. Here's one, it's about 4.4. Here's one, it's about 6.7. Here's one, it's about 7.6. Here's one, it's about 9.8. Here's one, it's about 10.7. There's one, it's like 13 exactly. And this is about 13.8. Okay, wow, that's a lot of solutions. Okay, now what about when is sine of 2x equal to negative 0.3? Negative 0.3. That would be about here. Yeah, let's say about like that. So this one's about 1.8. I'm going to mark these so you know what I'm looking at here. There, 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 there. Okay. Should be about 2.9. Should be about 5. 6.1. 8.1. 9 point, I don't know, 2. I'm really eyeballing this. This graph paper isn't that good. 12.2. 14.3. Okay, those are my guesses there. All right? Okay. The graph of y equals tangent, and of course if you have a ruler it would be much easier. The graph of y equals tangent of x is illustrated. Use the graph to estimate tangent of 1 and check your answer with a calculator. Okay, so let's see. 1's right there. So tangent of 1 looks like it would be about 1.3. Okay, and then find the correct one decimal place the solution of tangent of x equals 2. So tangent of x equals 2. And I'm going to do that for 0 to 8. So it would be this one, this one, this one. The red pen. Okay, so the first one looks like it may be like 1.2. Next one looks like it's maybe 4.2. And this one looks like it's about 7.3. Okay, those are my guesses. Okay. For that. And just, it said to check the answer with the calculator for tangent of 1, so why don't we do that? We're going to put the calculator into radians mode. Radians. Quit. And then we're going to say tangent of 1. The answer is 1.6, and I put 1.3. So, not such a good estimate, is it? So the real answer is 1.6 about. Okay, moving on. This is just a procedure to find a intersection on your calculator, which I think you've done before. So nothing new there. Let's use that procedure here. So I'm going to show you how to do it for real here. So it says, solve for x on the domain from 0 to 12, sine of x equals 0.431. So what you're going to do is you're going to go to y equals and you're going to program two things. One is you're going to program the sine function, and the other is you're going to program the function y equals 0.431. Oops. And by putting both of these functions in the calculator, now you may see where they intersect. First, you're going to graph it. And maybe we're not going to be able to see a thing. We're going to need to zoom. I guess it's graphing. Zoom, zoom. Let's do zoom standard first. There we go. Okay, so you can see that there are two lines there. And it says to find it for the domain 0 to 12. So let's go back to the window. And then we'll put 0 to 12. For xmin, we'll put 0. For xmax, we'll put 12. And then we know it ranges from -1 to 1, so we'll put -2 to 2. And then we'll graph. Very nice. And then it's going to draw the line 0.431. And you can see there's 1, 2, 3, 4 intersections here. So I'm just going to help you find the first one, and then you can find the rest of them. So first thing you're going to do is you're going to do a second calc intersect. And then you're going to say, oh, okay. Oh, the first curve is a sine wave, and you say yes. And then it says the second curve is the function y equals 0.431, and then you say yes. And then it says, what's your guess? And then you want to put the cursor as close as you can to the first intersection. Doesn't have to be exactly on top, but close to it. And then it finds it. It says that the intersection is at 0.446 x. So x equals 0.446. And then there are 1, 2, 3 other solutions, plus 3 other solutions. Okay? Alright, the next one has 3 tangent of x minus 2 equals 0. So let's put that into y equals. So we're going to clear that out. We're going to put tangent. Oops, we're going to put 3 tangent x minus 2. And so the thing is, we're saying, when does that equal to 0? And there's a couple ways to do that. One way is to put the function y equals 0 here. The other way is to use the zeros function. So we could like do, we'll graph it first. Okay. And then we're going to find where it hits 0. It's going to be here, 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 and here. We use the function second calc zeros. And then we'll say, oh, the left bound. So the left bound is, I can't even see the cursor. Do you see it? It says 4.5. I need to go way, oh, there it is. There it is. Left bound, here. Right bound, I'm going to go up to here. Enter. Yes, sure. So it's 0.588. 0.588. Okay? And then there's going to be 1, 2, 3 more, plus 3 more. Okay? Alright, now 2a. Says solve for x on the domain -5 to 5. And then the first one is, we're going to program it in, it's going to be 5 cosine x minus 4. And we want to know when this equals 0. So first we're going to graph it. Actually, we want to change the domain. We want the domain to be -5 to 5. So we're going to go back to window. And then we're going to say xmin is -5. Xmax is +5. graph it. Okay, and then when is this equal to 0? I guess it's equal to 0 here and here. So we're going to use the second calc 0 function. And then we're going to say, okay, the left bound, we need to move it to the left side of this point, enter. And then we move it to the right side of this point, enter. And then we guess, that's fine. And there it is, negative 0.644. Plus one other. The other one's right here, right? Next one, 8 sine x plus 3. So go to y equals, do 8 sine x plus 3. Then we graph it. And we're going to say, when is this equal to 0? It's equal to 0 here, and here, and here. So there's 3 solutions. Let's find the solution here. We find the solution by doing a second calc. Again, we're looking for the zeros, right? So we'll move on the cursor all the way over to here, to the left side of this one here, enter. And then we go to the right side of that, enter. Okay, and that gives us negative 2.76. Negative 2.76. Okay. And then, of course, there's 2 others, right? 2 others. Okay. Number 3. Solve each of the following for the domain 0 to 2 pi. Sine of x plus 2 equals 0.0652. So what you're going to do here is you're going to go to y equals, and you'll say sine of x plus 2 equals, and then we don't care what it equals yet, because what we're going to do is we're going to put in a second function, and we're going to put 0.0652, 0.0652. Now we say, okay, when are these two equal? Oh, and we want the domain 0 to 2 pi, so we're going to change our window from 0, and for 2 pi we could put 6.28, or we could put 2 times pi, 8, graph. So there's our sine wave, and there's our line. So there's 2 solutions, right? So let's find this one here. We're going to go second, calc, intersect, number 5, and then the first curve is that one, yes. Second curve is that one, yes. Guess. And so now we're going to move this close to the intersection. That's close enough. Enter. 1.08. 1.08. X is 1.08. Okay? And then we, and the y is 0.0652, of course. Okay? Now we're going to do letter C. So we're going to put this left side in. We're going to put x tangent of x squared divided by 2. And then on the other side, we're going to put x squared minus 6x plus 1. Now, Diana was just asking me today about what if you put a squared in here, wouldn't that get crazy? Yeah, it's actually, I said, well, the book doesn't do these kind of problems, but I guess, that doesn't count for calculator problems. Calculator problems, they can make them as complicated as they want to, and that doesn't, make it too hard for you, because the calculator is doing the heavy lifting. And I mean, something like this, they could even give it to a math studies exam question, because, basically, same thing. So I'm going to put an x here. Okay, x tangent of x squared divided by 10. Okay, then we're going to put the next equation in. We're going to put x squared minus 6x plus 1. X squared minus 6x plus 1. And now we're going to see where they intersect. So we're going to do second calc. Intersect is 5. We have some interesting looking things here. Wow, and I don't even see where the intersections are, so we're going to zoom out a little bit. What if we do zoom fit? Zoom fit. And then after that, we're going to do second calc intersect again. Okay, so that's probably the x tangent x squared. And then the other one's going to be a quadratic parabola. Don't see it. Don't know if it's been drawn already. Okay, so we're going to go second calc, and then we're going to do 5, which is the intersect. And then we'll say first curve is x tangent, yes. Second curve is x squared, yes. The guess is here, okay. So one of the intersections is 0.171. 0.171. And I don't know if there's any others. It's kind of hard to see this. Let me zoom in a little bit. So instead of zoom standard, I'll use zoom, or zoom, I'll do zoom standard instead. No, the zoom standard gives me that weird thing. Okay, so, but you see what you need to do, right? Okay, oh, here's that's pretty weird. This is the tangent, this is this one, right? Oh, and there's the quadratic. Oh, this is much better, actually. Okay, so you can see that there's a solution there. Wow, it's at the origin. So one of the solutions is at the origin. I guess that makes sense. No, it doesn't. I guess it's not really at the origin. Let's see where that one is. I'm curious. We'll do, maybe that's 0.171. We'll see. Second calc. And then we go to intersect. Oops, sorry, Diana, I'm going over time here. Intersection. Oh, that was it. Okay, so that was the one there. And there's one there too. Can you see? So there's at least 2, maybe there's more. But like from 0 to 2 pi, not sure how many there are. So we can actually change, the window size. We can say, oh, I want to see just between 0 and 2 pi, which is 0 to 6.28, or we could put 2 pi. There's the quadratic. Okay, yeah, so there's one here and there's one here, right? So there's at least plus one other one. There might be more. Well, I guess the others are off the screen, so that doesn't count. Last one, solve for x. And they give us a left side here and a right side here, and they give us a domain. So we're just going to put these, and it's getting pretty boring now, right? And you're like, okay, Mr. Tsubaki, I already know how to do this. Cosine of x minus 1 plus sine of x plus 1 x plus 1. Okay, so that's the left side, and the right side is 6x plus 5x squared minus x cubed. So 6x plus 5x squared minus x cubed, minus x to the third. And the rest of it is just delete, delete, delete. Oops. A lot of junk here. Cubed. Okay, now we'll graph both. One of them's like a cubic, and the other one's kind of a sine wave. And then we're going to see where they're equal. Oh, there's an intersection right there. Let's change our window so that it goes from -2 to 6, because that's where we want to see. -2 to 6. It's 6.28, but we can delete the rest of it. Okay, now let's graph it. And then we're going to find the intersections. So there is the sine wave. Okay, so there's like 2 intersections. There's this one and this one. So let's find one. We'll do second calc intersect number 5. And then first curve, yeah, first curve's cosines. First curve, second curve is x cubed. Guess, that's guess. That's fine. Okay, so the first one it gives us is 0.234. 0.234. And then to get this one, you just repeat it and you put the cursor close to this one. And that's it.